Hello everyone, my name is Gokul Ravi and I'm a postdoc at the University of Chicago. I'm going to introduce better than worst case decoding for quantum error correction with the click decoder. In quantum error correction, multiple physical qubits are encoded together to represent a single logical qubit. Some classical decoding is then used to identify quantum errors on the fly and correct them, but these classical processing requirements do not scale well. In traditional QEC decoding approaches for cryogenic quantum systems, information about the qubit errors flow from the cryo domain to the room temperature domain. Over here, complex decoder units are present, which decode the errors and send corrections back to the qubits. The decoding bandwidth to support practical applications will run into terabits per second, but this bandwidth cannot be supported at the 4 Kelvin to 300 Kelvin interface, and this is a severe bandwidth bottleneck. Recent alternative proposals move the decoding from the room temperature domain to the cryo domain. Now the decoding bandwidth bottleneck is resolved, but unfortunately there's a bottleneck in terms of power and thermal budgets, and therefore this is again a severe scalability challenge. In this work, we instead take a better than worst case approach to decoding. We separate trivial to decode errors from complex to decode errors. The trivial errors, which occur most of the time, can be handled by our very simple cryogenic decoder called CLICK, which sits in the 4 Kelvin domain. The small remaining percent of complex errors flow out of the fridge and can be handled by a state-of-the-art decoder. With this two-level decoding, both the bandwidth and cryo resource bottlenecks are alleviated. Click improves the scalability of classical decoding by many orders of magnitude. To learn more, please attend my talk in section 8A on Wednesday, the 29th of March.